You're listening to the Skeptics Guide to the Universe, your escape to reality.
Hello and welcome to the Skeptics Guide to the Universe. Today is Tuesday, October 22nd, 2024, and this is your host, Stephen Novella. Joining me this week are Bob Novella.
Hey, everybody.
Kara Santa Maria.
Howdy.
Jay Novella.
Hey, guys.
And Evan Bernstein.
Good evening, folks.
How's everyone doing? Kara, happy belated birthday.
Yay.
Thank you.
Kara.
Yes.
Would it be inappropriate for me to ask you how old you are?
No, not at all. So I'm very public with my age. I had my 41st birthday, and I've been polling a lot of my friends about this. 40 was a nothing burger. 41 was the worst existential crisis.
What?
It's such a weird thing. It's like
Doesn't
once
make
you're
sense.
in the decade, I think because we tell ourselves the year before, we're like amping ourselves, like, oh, I'm going to be 40, I'm going to be 40, I'm ready to be 40, I'm going to be 40. But then like nobody's ready to be 41. And then after that, you're almost 50, and then you're almost 60. And that's just how it goes from there.
The only thing I experienced like that was when my older daughter went to college. So this is the first kid going away to college, right? The first year, we drive her down there, she gets set up, she goes away, and that's it. And, we dealt with it emotionally very well. The second year, leaving her at college, the second year was for some reason so much worse.
Harder.
It was
I know.
harder.
It's because it's like also when you get a tattoo. Your first tattoo, you're so freaked out about it that you get it and you go, oh, that wasn't that bad. And then your second tattoo, you have this false sense of security that it won't be that bad. And then you're like, oh my God, that really hurt.
Yeah.
I don't know. There's something about...
So we psych ourselves up
so.
to a certain degree
I think so.
at the initial...
For something big.
Yeah.
And then the next thing is just as big, but we don't expect it to be. Mm-hmm. It even feels bigger. So, but I will say, I had a great weekend. I had a lovely dinner. I spent time with a lot of friends. I hosted a poker game at my house, which was really fun. And then on Sunday, I went for the first time in 20 years. No, I did not. I went to my new church, which is adult gymnastics.
Oh, cool.
Oh.
Whoa.
Wow.
I
Careful.
thought I was going to be, well, I was really out of shape. I'm very sore still. We're recording this on a Wednesday and I'm in a lot of pain.
Tuesday.
But you're right. It's Tuesday. That makes me feel a little better. We usually record on Wednesdays.
Gymnastics at 41?
Yes, gymnastics at 41. I thought I wasn't going to be able to do anything. Like I told the coach at the beginning, I don't think I can do a cartwheel anymore. My legs are going to be bent. I'm probably going to pull my groin. Like I'm so out of shape. But not only did I do cartwheels, back walkovers, a round off back handspring. I mean, with a spot, but it comes back.
Wow.
It's kind of amazing. I'm not in shape like I used to be. I don't have the upper body strength.
Well, you're
that
41,
I did.
Kara. I mean, come on.
But I actually think it might come back if I just keep doing this.
Why wouldn't it?
Right?
Yeah, absolutely.
Exactly.
Good for you. I remember in my early 40s doing my last handstand and thinking, I'm never doing that again.
But you
really
can.
hurt.
You can. And that's the thing. The conditioning courses, the stretching courses that they offer, and then they have like beginner, intermediate, and advanced gymnastics, all for adults. A lot of people who are older, the way they stay in shape is they engage in sports or different things that are, I don't know, fun. Like you have to make your workouts fun. If they're not fun, you don't do it.
You got to enjoy it.
And I've struggled with that a lot in my older years because looking back, the thing that was really fun for me was like stunting and gymnastics and cheerleading. And I think I just thought that you can't do it as an adult, but you can. So
Just do it a little differently, but yeah. So we've started giving each other, like in our family, experience gifts.
Oh, I love that.
Yeah, so I've done so many different things, in the last couple of years. Like
the glass blowing.
Right? My daughter got me a fencing lesson that we took together, which was fun.
Wow, how to sell stolen goods? Awesome.
Yeah. And then, so over the weekend, my wife and I went to her birthday gift, which was a cooking class in New York City, where this like master chef, this guy, told us all of his, credentials, taught us how to make fresh pasta with pesto sauce. It was awesome. It was awesome. So he was a character. This guy's like, Italian, speaks in a heavy accent. And he, of course, very appropriately snobby about Italian food versus American food. Because, of course, those of us who have been to Italy, the food there is just amazing.
It's superior.
It's superior. There's no question.
Without question.
And so he's like, you guys don't eat Parmesan cheese here. Like, you have Parmesan. That's not real cheese. We have Parmigiano is the real cheese. And he's telling us all the differences between Parmesan, like from Wisconsin, and Parmigiano from Italy, which
we would know that very well.
Totally.
Kind of
Jay and I got Jay a chunk of Parmigiano, in Arthur Avenue in New York for his birthday, and we're still both eating it. I got myself a chunk too. It's amazing. It's like it blows away anything you can get like in the store, of course. But he did say one thing that I'm like, okay, I got to talk to this guy. He's like, he trashed GMOs. He's like, don't buy GMOs. Like, our food's better because blah, 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 blah. It's like we don't use GMO.
Uh-oh.
He like threw that in there.
Yeah, step too far, bro.
So at the end of the lesson, I said, so what's your problem with GMOs? And he's like, did you ever taste like a tomato, like an Italian tomato versus an American tomato? I was like, oh, that was... So I'm thinking that was the perfect example for him to bring up. So I said, well, it turns out you've never eaten a GMO tomato because there are no GMO tomatoes on the market. And he was like, no, he was shocked, and it was clear, without giving the blow to blow, it was clear that in his mind, GMO meant anything not completely natural. You know what I mean? He had no idea what it actually was.
Oh, man.
Yeah.
And I'm explaining to him, it's like, yes, because the tomatoes that are full of flavor are heirloom tomatoes that are bred for flavor. And the ones in the supermarket are cultivars that are bred for shelf appeal and durability and not for flavor.
Long life, yeah.
And so they are relatively flavorless compared to like heirloom. They're also, if you're buying an heirloom at a local farmer's market, it's going to be a lot fresher. It will not have ripened off the vine as much. But none of them are GMO. It has nothing to do with GMO. And he said, I believe you at the end, but I don't know if he's just getting rid of me. But
and right when you left, Steve, he went, oh, yeah.
Maybe he'll go home and Google it.
I told him, I said, don't believe me. Look it up. It's like, but I do think there's probably a lot of that attitude out there where people like don't really know what GMO means. It's just a generic term for anything corporate or industrial or, and not like from the farm to table. It's like it's just a vibe. It's not a specific thing.
It's like homeopathic items. It's similar. They didn't know what it really meant. They just thought it was
herbs. They thought it was herbalism.
Yeah, that it was just like alternative treatment.
Or natural.
Like, no, homeopapathy is an actual thing.
It's a specific thing. It's witchcraft. And when you tell people who have no idea what it is, they don't. They've never believed me. I've never had somebody just straight up believe me when
they have to look at
when I explain to them for the first time what it is. Yeah, like it can't be that. That's crazy.
Yes. Correct. That is crazy. You're right.
But it's interesting that, because I follow the literature on science communication very closely, as we all do here. And, when we talk about the knowledge deficit problem, like a lot of topics are not a knowledge deficit problem. Denial of global warming is not a knowledge deficit problem. But being anti-GMO, it turns out, is primarily a knowledge deficit problem. That it is one of the, I think, pseudoscientific beliefs that can be corrected with information, because the people who have anti-GMO beliefs are misinformed. They just simply have incorrect beliefs about what a GMO is and how it's regulated and et cetera, et cetera.
Yeah, they've been sold a dialogue.
They've been lied to. They've been straight up lied to by propaganda, and like transparently so, and it's easy to disprove.
Interesting. Yeah, not an uncommon phenomenon these days.
Yeah.
Sure, and it's reinforced. There are echo chambers, and it gets out there, and people just accept it.
Mm-hmm. Interesting. So yeah, I was at first a little surprised, like, oh, I get it now. He has no idea what GMOs are. He just thinks it's anything corporate. All right. But I got a lot of good advice from him on like how to get, because he went over the whole. I just was telling my wife about the fact that like most olive oil is fake, because it is a huge, it's a huge scam.
Thing. Oh my gosh,
and it got much worse during the pandemic because there was supply line issues, and so you have to get the DOP, which is a designation that says it's verified that it comes from where it says it comes from. And you know what I mean? And that it is what it is. For example, you could you could label something a product of Italy if you have an office in Italy, even if it's sourced elsewhere. So those regulations are very, very loose. But if it says DOP, then it has to fulfill all these specific criteria about it has to actually come from the place that it says it's from. And so, yeah, if you buy olive oil off the shelf in the grocery store, chances are it's not actually olive oil. You have to make sure that the brand that you're getting has been verified, both for its location and that they're using actual olive oil.
So what you're actually just getting vegetable oil?
Just there's cheaper vegetable oils.
Yeah.
But then why isn't it called vegetable oil?
Because olive oil markets better. You could sell it.
They allow for it to be called.
You can charge
olive
more.
Oil. Yeah, right.
But there are brands that you can trust.
There are. You got to find that there are. You can get real olive oil in the States. You just got to know which brands are verified. Don't make any assumptions. And you may have to get them like imported olive oil. And you're going to pay. It's going to be more expensive because it's the real deal.
I'm still working
Steve,
on this.
before I forget.
Yeah.
We have that knife making class that I bought you for your birthday.
I know. That's the next thing we're doing is a knife making class. That's going to be fun.
Nerds.
No, it's great.
No, I love it. It's great.
It depends on the knife you're making.
So at some point I'll make you guys, Joss and I will make you guys some pesto sauce, like real pesto. It was super good. It's not that hard. You just need a shit ton of fresh basil.
It does.
I'm running low on my Parmesan, Steve. We got to go get more.
Yeah, I'm going to have to get more. I just had it today. It was so good.
God, it's so
Parmigiano.
good. It's ridiculous.
Parmigiano, Jay. It's Parmigiano.
Bam, Parmesan.
All right, Carrie, you're going to start us off with what's the word?
Yeah, this word was recommended by Don from BC, from Kelowna. Hopefully I'm pronouncing that right, British Columbia. He said, I'm a first-time writer. I've been enjoying your show. I would like it if you would explore the etymology of the word annular. Obviously, annular means ring. Well, thanks for blowing it. Spoiler alert there, Don. But what about all the related words? And then he said annual, annuity, and yes, dare I say it, even anus.
Yeah,
I'd like to know what the original root word was and how these are all related. So yeah, I did a little digging there for you. And you are correct. When we look at the etymology of the word annular, really it does go back to the Latin for ring. And guess what the Latin for ring is?
And you.
Yep.
And
annulus?
Anus?
Anus. Yeah. I'm sure it's not pronounced anus.
We're trying not to say it, but
anus.
Anus.
Anus, from the medieval Latin annularis, but that comes from annulus, which comes from anus, probably, which means ring. So the first time that it was used to mean ring-shaped looks like it was in the 1500s. As you dig into OED, has like a good listing of early uses in textbooks. Well, actually, here's a description even older. From 1560, geometrical practice. Divide that annular superficies. It's all written in like weird old English into not old English, but older English into three other, every one of them equal to the same inward circle. 1664 by H. Power in Experimental Philosophy. An annular body like a wasp with some 8 hoops or rims. So this word, she voided. This is a fun one. Philosophical Transactions, 1767 by R. Smith in the Royal Society. Volume 5692, in case you're interested. She voided a large annular worm. Do not want to know what was happening
voided
in that description.
I doubt it's like voiding a check.
No. 1833, annular nebula exists, but are among the rarest objects in the heavens. That was Herschel, writing about astronomy. And then you see annular systems of Saturn, annular tables. So yes, all of these ring-shaped things, more and more descriptions in the literature. But let's dig a little bit deeper, as was requested here by Dawn. Well, the word anus, the inferior opening of the alimentary canal, which was coined in the 1650s, also comes from that exact same root. And it's actually, if we go back even before the Latin annus, it is believed that the PIE, right, the Proto-Indo-European root is anno, meaning ring, so-called for its shape. We, of course, know about the annular eclipse, which is an eclipse in which you do have to wear your vision protection the entire time because that ring is quite visible and quite bright and can injure your eyes. But how about another question here, one that I came with myself, because I was like, okay, thinking about astronomy, thinking about these different terms, and of course thinking, I think last week we got a lot of feedback on, was it Janus? Do you guys remember?
Yes.
We got all these emails about the god.
Either,
right?
Yep.
Right. So I was like, okay, what about Uranus, which is like the modern way that astronomers pronounce Uranus because they don't want little kids to laugh in the audience. What about Uranus? Like, when did where did that name come from? Is it derived from, I mean, the second half of the word is anus, right? From annular. And the more that I dug, the less sure I am that root is even a part of it, because it seems to have come from the Proto-Greek word versenos, because the Greek god of the sky, Oranos, which eventually became Uranus, and that was what the planet was named for, the ancient Greek deity of the sky. The root of Oranos was versenos, which is apparently derived from the PIE urs, which means to rain or to moisten. So I think this is an example of a sort of convergent evolution where they look the same, but they came from two different roots.
Is that when the V and the U were kind of interchangeable in language?
Yeah. I think so. I mean, and of course, which language, right? But so it is interesting that some of these words which appear to come from similar roots might come from completely different roots. But then we can come up with a what would you call it? Like anachronistic description for why they are what they are. So Uranus apparently has nothing to do with your anus, sadly, that ring of flesh.
Might be a relief to others.
But when we think about all of the different examples of words like annuity or annual or things like that, we are coming back to this idea of the year going around.
Right,
and that does seem to have, some sort of circular root there, a ring-like root. So yeah,
neat.
Very, very interesting word, and used in a lot of different fields, right? Like, Steve, do you ever talk about, I mean, I know you're not a dermatologist, but annular, I've seen a lot of reference to sort of like annular markings or annular. Yeah. Very, very common in medicine, very common in lots of different
Do you like
fields.
when you have a parasite and like a ring appears on your skin? Kind of
like ringworm?
Ringworm.
Yeah, ringworm.
But ringworm's not a parasite, right? It's a fungus?
It's a fungus.
No.
Yeah.
It's a fungi.
But you would definitely call that an annular rash.
Yeah.
Yeah.
Yep.
Cool.
All right. Thanks, Kara.
Yep.
Jay, tell us about this recent launch of the Europa Clipper mission.
NASA's Europa Clipper mission, this launched on October 14th, right? Not too long ago. And this is very significant. This is a huge step in the search for life beyond Earth. So there's a lot of excitement about, SpaceX, and, there's been lots of really cool space-related stuff this year. But this one, I think this is the biggest news possibly of this year that we're going to hear about. So if it goes well, Clipper will arrive at Jupiter in 2030. It's not that long from now, before you know it, And once it's there, it's going to begin its mission to explore Europa, which is one of the most likely places in our solar system to harbor life. So Europa, it isn't just an icy moon. I know you've seen T-shirts, with it's like a snow cone. Yeah. Scientists believe it hides, it has a ton of ocean water beneath the frozen crust. We've known about this for a long time. And what we think is possibly under that crust, not only is there twice as much water as Earth's oceans combined, but there probably is all the makings to have life beyond that planet. The planet has a rocky core. It generates a lot of internal heat through all these tidal forces. And there's a lot of pumping of minerals into the ocean. There's a lot of similarities here. So life on Earth, as you know, it can survive in extreme environments. So we know that bacteria, like chemosynthetic organisms, they can live near these volcanic vents and all that stuff. There's a lot of evidence to show that there could be life there. So Europa's hidden ocean absolutely could host similar forms of life, and it does not need sunlight. So this is all, adding to the reason why NASA decided to do this, because there seems to be, very, very good conditions there to host life. Clipper isn't taking a direct route to Jupiter.
Of course not.
Yeah, Bob.
Why would it go straight there? Get there quick.
If it went straight, it would miss.
I got to tell people, Bob, because they don't know everything you know.
I know.
You know what I mean? So the spacecraft has to fly by Mars. It gets a gravity boost. Boom, like that, It swings back around to Earth, grabs another assist, and it finally makes its way to Jupiter, and it takes years, right? And once there, it'll orbit Jupiter, and then it will conduct 49 close flybys of Europa over the course of 4 years. They think it might come within 16 miles of the moon's surface. That's freaking intense. Wow. That is intense. That is so freaking close. So close.
All the cameras are working.
So close.
How close is it?
I'm going to tell you, Kara, thank you. My God, the only one. That it could actually fly through some of the ejecta that, from the what would you call those? Like the hot springs that shoot.
Yeah, like the plumes.
The plumes, yeah. And imagine that. It goes through one of those plumes and it's going to be able to really analyze what's in those plumes. And it was specifically designed to study Europa's magnetic field, its gravity, its ice shell, and its ocean composition. And, what makes this mission really exciting, though, is its ability to sample material, like I said, directly from Europa's surface and plumes. Now, this is a big freaking deal. Those geysers, they shoot up water vapor. It's erupting all the time. And if Clipper can fly through one of those plumes, man, it's going to gather key data on the organic molecules that we expect to find there. And that will tell us just how habitable Europa's oceans might be. So the Clipper missions won't directly search for life, right? They're not going to specifically be looking for life. They're just going to be looking, around the edges pretty much. Instead, they're going to try to determine whether Europa has the conditions, like I said, and if Clipper does detect organic compounds or there's any other evidence of possible life there, it will justify future missions, which means the money will suddenly become available. And they're also talking about maybe a lander to explore the moon's surface, which would be incredible. A lander mission would be a very long way off, though. I mean, probably the 2040s, but this is how it works. We're not churning out, these missions because the money is not there. And, it takes a lot of effort to get billions of dollars to go to something that might not find anything. You know what I mean? So we need more proof. And we're hoping that this mission will get enough data to say, hey, you know what? We need a lander, which would be amazing. Hey, do you guys know, could we potentially put boots on the ground there, or is it just too far away?
You mean people?
There are people at NASA who really want this to happen, but they are not hopeful.
Too far away, the radiation's heinous.
Yeah, I guess you're right, Bob.
You mean people's boots?
Yeah, I
didn't even know you were asking that. I think even the lander itself is not fully in the cards yet.
We would no, it isn't. Absolutely not. Yeah. They need more evidence to get the funding for that. But the first several probes that we would send there would be uncrewed, I'm sure, right? We're not planning on sending people there. But is that even in the cards? I know, Bob, you're saying that the radiation is horrible.
It's too far, and even if you get there, the radiation is nasty. The biggest challenge, as we know, we can't even go to Mars now because it's just too far.
Also,
the radiation,
what's the point?
Just the galactic. Just the radiation from the sun and the cosmic rays are just that's a deal killer right there. No matter even for whatever reason, even if they were just going to orbit Jupiter.
Yeah, I agree.
It's not going to happen. That's not going to happen for quite a while.
I agree.
The electronics in the Clipper have to be shielded just for that to function in the
definitely. Yeah, you're right, Steve. So what's cool, they have these massive solar arrays, like these 100 feet wide solar arrays that are the largest that NASA will ever deploy to date. And they're designed to generate 700 watts of power. But why is this significant? Because Jupiter receives only 3 to 4% of the sunlight that reaches the Earth, right? It's so far away that the sunlight intensity dramatically drops. So they need...
Yeah, so if you had a solar panel at Jupiter, it would be getting 3 or 4% of the energy that the same solar panel would be getting in orbit around Earth.
Yep, absolutely. So they got to make these giant ones to give it enough power, but they can do it. We have the technology. So I'm excited. To me, there's never enough of these missions. I just want us to be doing this multiple times a year and really explore our solar system. So I'll be alive when this one lands. We'll see what happens.
Yeah.
So Jay.
Yeah.
I wanted to share that last week a friend was in town and randomly stayed with me because she was meant to be at the launch of Europa Clipper. But I don't know if you guys remember, there is a pretty horrific hurricane happening at the exact same time. And it was a really tense day because Clipper had already been put in position and they had to pull it back and keep it. It was in a hangar.
Mm-hmm.
Wow. It was just surrounded by like thin metal in the middle of a hurricane. And it was so lucky that this complex machine, which was, had years and years of science and engineering loaded onto it, was just waiting for this hurricane to blow over. It could have been destroyed.
Yep.
It was a very scary day.
Yeah, it did well, though.
Yeah, thank goodness.
Jay, do you know how gravity assists work? Like the basic physics of a gravity
Absolutely.
system?
Yeah, he told us it was like, choo.
Yeah, like basically you loop it around and it picks up speed as it goes through the gravitational field of whatever the body that they're using for the boost, and then it shoots it around on the flip side,
Yeah, so that's the effect, but that's Bob is like having the same reaction I have. It's like there's a level deeper. I'm sure there's actually even levels deeper layers. Still. But basically, where's that extra momentum that the satellite picks up coming from? This whatever
the planet.
It's coming from the planet.
The body.
Of course it is.
Body.
And but not just that, but think about it this way. So essentially the probe will add the velocity of the planet around the sun to its velocity.
Once it's within that kind of gravitational range.
Depending on how it swings around. You could swing it around so that it leaves the planet going away from the direction the planet's moving around the sun, and then it will slow down. It'll subtract. That.
Because think about it. If you go towards the planet, just go towards the planet, the gravity's going to pull you in and save you some energy, right? But then as you're moving away from the planet, it's going to pull you back. So it's kind of like a wash. So it's more complicated than just the gravity. It's really the direction the planet's orbiting and the approach vector you take when it's in its orbit.
You can think about it this way, that relative to the planet, the probe is going to be leaving at the same speed it enters, because that's what Bob said. Whatever velocity it gains from the gravity, it's going to lose leaving the gravity.
Right.
But if it's going in the direction of the planet, that relative velocity is going to be adding the velocity of the planet around the sun. So it's speeding up relative to the sun, not relative to the planet. Does that make sense?
Very good, yes.
But that's why if you go in the opposite direction, you're slowing down relative to the sun.
Yeah.
It was a little bit more interesting. And
yeah, it is.
Yeah, so you could speed up or slow down. It's all about the trajectory.
Like I said.
Does that mean you can't use the sun to get a boost?
Right. I guess you can use the sun to get a boost in your velocity around the galaxy, right? It has to be relative to something that it's orbiting, but not relative,
not in the
within the solar system. Yeah.
Right. That gets you nowhere.
Right.
Okay.
Yeah, and one of the reasons, another angle to this that makes it interesting is when I was getting upset about how long it's going to take to get there, it's mainly because rocket fuel, is it's expensive and relatively inefficient, the whole rocket equation thing. So in order to maximize cargo and minimize fuel, they do it's a Hohmann orbital transfer. So basically they try to find the balance between how much cargo you can carry and how much fuel you need. So it takes a long time. It's efficient, but it takes forever to get there. Now if we had crazy, real like nuclear rockets, like a torch ship.
Yeah.
Then you could do I think it's called a Brachydstone orbit, and then you could just basically go there you go to where it's going to be when you're going to get there, and if it's actually fast enough, you could accelerate to the midpoint, turn around, and then decelerate. But that's just like crazy. That's about
not with chemical rockets.
Rocketry.
Yeah.
No way. Not with chemical
fusion.
rockets. You need to accelerate for days or weeks, which may never be really possible. But there are some designs for nuclear rockets that might make a torch ship feasible. But we'll have to see. But it's fascinating to get into some of those layers.
Yeah. All right.
Okay.
Thank you, Jay, and thanks for that additional info, Bob. So Guys, I'm going to talk to you about a new cognitive bias.
All right, talk to me.
Whoa, new one? You mean newly named?
Whoa.
Well, I don't know.
But we had these.
I think there is a new name involved here. It's not something that we have talked about.
Oh.
I'm going to tell you
new to us.
You want me to tell you the name and then I'll describe it to you, or you want to guess?
Okay.
All right. So the name is the illusion of information adequacy. It's pretty self-explanatory.
Sounds a little Dunning-Kruger-y.
It is a little Dunning-Kruger-y. It is. So what the research was, the study that demonstrated this phenomenon, what it did was they gave 3 groups of people, right? They study subjects. They broke them up into 3 groups, and they presented them information about a controversial topic. And then to group A, they gave them only one side of the information. In group B, they gave them only the other side of the information. And in group C, they gave them both sides of the information. So in each group, they asked the subjects, like, what position do you take? And they also asked, do you need any more information? Do you feel like you have all the information that there is?
That should always
Did
be
anybody
no.
say yes to that?
Right. How is that not always no?
Yeah.
So, the majority of people in all 3 groups said that they had enough information and that they had all the relevant information that there was. Now, the third group actually did have all the information, but that doesn't mean that they weren't biased, because they just, they assumed they had all the information. It happened
like the other side
happened to be correct, but the other 2 assumed they had all the information, and they didn't. They only had half of the information. So that's the illusion of information adequacy. They also asked the people, how do you think other people will feel about this issue? And they assumed everybody would agree with them.
Mm-hmm.
Wow. Right? Because, of course, if you think you have all the information and it's all pointing in one direction, then, of course, other people should come to the same conclusion, of course. There was one difference between the group that had the 2 sides of the information and the 2 groups that had only one side of the information. What do you think that was?
One difference between, the groups that had both sides and just one side?
The one group that had both sides was different in one important way from the 2 groups that only had half of the information.
They were different, inherently different?
No,
there's too many choices here. This is too open-ended.
Their reaction to the information was different.
It was more measured. It was more waffly.
It was more measured, and therefore it was less confident. So the people who had half the information were more confident in their opinion.
Oh my God!
The people who had the full information were less confident because, of course,
it's like an inverse.
Because it seems simpler to them.
It sounds like a scientist versus a layman.
Exactly. Yeah. So the people who had all the information, they're getting both sides. So it's complicated. There's some information going in one direction, some information going in the other direction. They still may have been favored one side or the other,
but they were grappling with uncertainty.
The people who had half the information are like, I know everything I need to know. This is simple. I'm very confident in my answer, and everybody will agree with me. That was basically how they reacted to having half the information.
Of course.
Right.
It makes perfect sense.
It does intuitively feel so correct based upon our anecdotal experience with echo chambers and social media and just people out there in the world. It does seem that this is probably a very common cognitive bias, the illusion of information adequacy. This is sometimes we express this as, people consume information as a narrative, or information is communicated as a narrative, right? And so people adopt a narrative, a story about a situation, and that story is how they organize and filter and think about information. Right? They don't think about facts. Like, here are the facts. They think about, here's the story. Does that make sense? So here, if people are given just one narrative, one side of the information, that narrative is sort of internally consistent and complete, and it tells a consistent story. We find that very compelling. Right? That's more compelling than, here's a bunch of facts, some of which point in one direction, some of which point in another direction. Which is why you should be very suspicious when you are handed a nice, clean narrative, or any narrative, or any package of information. You always have to, and we've discussed this before, but then this sort of puts it into a good sort of cognitive bias kind of framework. You should always ask, this is just critical thinking 101. Well, do I have all the information? What does the other side say? Who disagrees with this? Why do they disagree with it?
Yeah.
What's the full story here? You have to assume you're missing information, because that is almost always going to be correct. You're probably always missing important information.
Mm-hmm.
So that's, I think, the difference between, metacognition and not engaging in metacognition, right? Critical thinking and just going with the flow, cognitively speaking, psychologically speaking. You hear a narrative, the narrative is compelling, you believe it, that's the narrative. As opposed to, wait a minute, is this the whole picture? Who disagrees with this? How could this be wrong? That's a metacognitive sort of critical thinking approach to hearing it. Now, we encounter this ourselves, and we've encountered it in people that we talk with. So I've noticed, for example, that when someone, for example, reads a book or watches a documentary, they're often getting a narrative, right? Or reads an article, right? That article has a narrative, that documentary or that book. So I remember I was speaking to somebody once, this is years ago, who read the book The Aquatic Ape. You guys know that book?
Oh, yes.
The idea that humans,
20 years ago.
that human evolution went through an aquatic phase, and then you could explain a lot of our anatomical features, whatever, as adaptations to an aquatic life for a period of time. It's all bullshit. Like, it's all evolutionary, just so stories. It's all nonsense. It's completely evidence-free. It's just somebody completely riffing. But if you only bring up all of the points that seem to point in that direction without bringing up any of the counterpoints or the pieces of information that cut against that theory, it could seem superficially very compelling, especially if you're not an evolutionary scientist, right, or somebody who's very familiar with it, or if you've never read a critique of it. You just read The Aquatic Ape, like, this is it, man. This. There's so much evidence. There's so many points in this favor. It's like, yeah, because you're reading one side of the story. You're just reading. Or people who watch Jay, I know, like when you first watched Loose Change, the 9/11 conspiracy movie, it's a documentary telling a narrative that's all in one direction. So it could seem like, well, something's got to be going on here. This is like there's too much all pointing towards this, this one narrative. So, but it's a good example of how that doesn't, in and of itself, that doesn't mean anything. In fact, that should make you more suspicious. If you're not hearing conflicting information, it's not because it doesn't exist. It's because it's not part of the narrative that was packaged and that's being handed to you. This also, in my opinion, explains why, we're as of recording this, we're exactly 2 weeks out from an election in the United States. And, we've, whatever side of the political spectrum you're on, we're all sort of experiencing this. How can the other side believe what they do? Both sides think that the other side is destroying the country. It's, there's incredible divisiveness. It's because at first approximation, most people have half the story and think they have this illusion of information adequacy. This is not a false equivalency. I'm not saying that they're both equal. I'm just saying that is a good explanation for why there could be such a fantastical disconnect that both sides think, how could the other side believe what they do?
Right. Like, that's not the explanation for for the content.
Right.
It's an explanation for why this election, as opposed to the last, that there's been almost, I think over my lifetime at least, a systematic widening of the gap between the two parties.
And if you've been following the horse race, which I try not to, but I can't help myself, it's the pundits are all marveling at how this election, nothing seems to matter. Nothing matters. Yeah. It doesn't matter who says what. It doesn't matter who wins the debate. Nothing matters. Nothing moves the needle.
Yeah.
So it's just defying all political logic and all history, because nothing's moving the
needle. It's just
needle.
Doubling down on exactly what you said.
People have already they're already taken their sides, and then no information can alter the narrative that people are already sorted themselves into, except for that little sliver of undecideds.
That's what I was going to say. It's why we're so flabbergasted by the concept of an undecided voter in this go around. Yeah. Like I feel like there have been elections in my history where I was like, these are interesting. These undecided voters, they're bringing up interesting moderate views, and I feel this way about this and that way about that. But now I'm like, who are these people? I want to study them.
Mm-hmm. Yeah, or undecided is also another way of saying unspoken or not declaring, right? They're keeping it to themselves.
Possibly, but I did read a good article about it, though, that interviewing people who were quote-unquote undecided, and their conclusion was a lot of these people, they believe something on each side. Right.
Which is an interesting
thing. And it's a dilemma. Because, like, I don't know. This person is horrible in this way. That person is horrible in that way. I don't know which one wins. And they're just sort of stuck in the middle.
That's why this fascinates me, because historically, being undecided, I think also meant that you believed some of what's over here and some of what's over there. But the candidates were often more moderate in their approaches. And so the polarization is so severe now that there's this kind of, I don't know what you would even call it, like vacillation with undecided voters. Like they feel extremely about this one thing and then extremely differently about this other thing. And that fascinates me.
I think that it might be the undecided voters have not resolved their cognitive dissonance. I think that's,
for sure.
that's why they're undecided. I think a lot of people have resolved their cognitive dissonance by just saying, well, that's not true, or that doesn't matter, or it's irrelevant, whatever. They've come
I'm picking my battles here. This matters more to me than
this is important, and that's not really going to happen, or whatever they think. Right. But if you can't just rationalize away half of the story, then it's a genuine dilemma. Depending on what you believe. Obviously, I'm not saying I don't think there's a dilemma, but I think depending on which pieces of information you believe about what's going on.
Yeah,
it is fascinating. It's just. If it wasn't going to determine the future of the world, and I was just looking at this as an academic sort of interest, it would be fascinating. We'll see. We'll see what happens in 2 weeks. See. All right. Mm-hmm. Bob, tell us about seeding the atmosphere.
Okay, so you got a group of climatologists, meteorologists, and earth scientists, but wait, what do you call them? You can't just call them a group. What would you call a group of climatologists?
Climatologists?
Oh, a
climate scientist,
a gathering,
a degree,
like gathering storm.
Now I'll come up with just a random name. A hockey stick of climatologists, meteorologists, and earth scientists recently have shown that, according to their model, diamond dust in the atmosphere would be an effective way to rapidly cool the planet. So how and why did they determine that? And how expensive could all that diamond dust possibly be? All right, so this is from the journal Geophysical Research Letters. The name of the study is Microphysical Interactions Determine the Effectiveness of Solar Radiation Modification via Stratospheric Solid Particle Injection. Nice read, that study. So geoengineering, or more specifically climate engineering, is the deliberate large-scale attempt to modify Earth's natural systems to combat climate change. Okay, you've heard of geoengineering before, but climate engineering is a specific type of geoengineering. So these types of planet-wide changes are, of course, they're pretty scary, both financially and existentially. Since if something goes wrong when you're trying to do some geoengineering, it could go wrong in a really, really big way, right? So it should be not done lightly, obviously. Some scientists claim, though, that dramatic climate engineering is becoming increasingly imperative, especially when you consider that some recent research claims that we are near or at a tipping point in our climate. Steve, have you come across any of this research that talks about this tipping point and how close we are?
Oh, yeah.
Yeah, because we don't know exactly where that tipping point is.
No.
But let me discuss what that is. Now, not much scares me, but climate tipping points absolutely do. According to the IPCC, which stands for Intergovernmental Panel on Climate Change, they describe tipping points as critical thresholds in a system that, when exceeded, can lead to a significant change in the state of the system, often with an understanding that the change is irreversible. So what would happen then is that you'd have these small changes in some of the elements in our climate, and they would create what they call a reinforcing loop that can then tip the climate from our current stable state relatively stable, into a completely different state. And I don't think we have really much of an idea what that new different state would be. So now if we actually are at or near a tipping point, then the key thing here then is that if that's true, then there's some strategies that probably won't be good enough anymore. One example is taking carbon from the atmosphere and sequestering it. That's something we've talked about on the show. I think it's a wonderful idea. They've got these large scale machines that can and have been constructed to show that you can remove significant amounts of carbon from the atmosphere and sequester it underground or whatever. And that would be fantastic if we can do that, of course, on a large enough scale. And if it's relatively inexpensive. But if we are truly at or near this tipping point, then these scientists would contend that, removing carbon, which would decrease warming, wouldn't be good enough because the tipping point would still happen. So to avert that, what we need, according to them, is not a decrease of warming, but a rapid cooling of the atmosphere. And one of the best ways to accomplish that is with solar geoengineering technique called SAI, stratospheric aerosol injection. So we know that injecting an aerosol into the stratosphere, doing that with planes, we know that it will cool the Earth, mainly because volcanoes do it all the time, right? That's exactly what they do. They're throwing these aerosols into the stratosphere, and you can measure the cooling that's happening. So we know that works. So that's actually a kind of a big bonus to watch natural geoengineering and learning from that. So now an aerosol, an aerosol is simple. It's just a tiny solid or liquid particles that are suspended in the air. It doesn't refer to the particles themselves because the air is an integral part of what an aerosol is. It could be air, it could be some other gas is required as well for an aerosol to be an aerosol. Now, fog is an aerosol. I didn't know that, but yeah. So smoke is an aerosol. And other particulate pollutants in the atmosphere. These are aerosols as well. Perfume from an atomizer, that's an aerosol too. So now the stratospheric part of stratospheric aerosol injection is also critical. The stratosphere is the second layer of the Earth's atmosphere going up from the Earth. Humans live in the lowest troposphere, and all our weather happens right here in the troposphere. Not much weather going on anywhere else, actually. The stratosphere doesn't have things like rain then, and that means that if you put aerosols up there, they will tend to linger for far longer periods of time than they would in the troposphere where we are. So what are they doing when they're hanging out in the stratosphere? What's going on? Aerosols can increase the albedo, or coefficient of reflectivity. So a white planet has a very high albedo, a dark planet has a very low albedo. It's just how much light is being reflected back. The more we reflect the sun's rays, the more quickly Earth will cool and hopefully not only help with our global warming, but also prevent the potentially catastrophic tipping over event into a new stable climate, which of course, almost certainly would be inimical not only to our civilization, but the surface biosphere as we know it as well. It would not be a good thing. No scientists are saying, if we tip over to a new stable climate, it'll be better. Nobody's actually saying that, even though pretty nebulous what that new stable climate would be. Now, the most commonly discussed aerosol in this context is usually sulfur dioxide. If you read about this, you'll see there's lots of talk about sulfur dioxide. We're very familiar with how that has cooled the Earth, like I said, in the past, due to volcanic activity. Unfortunately, there's some downsides to sulfur dioxide. It causes acid rain all over, not good. And they also think that it might disrupt the ozone layer and impact normal weather patterns. So yeah, sulfur dioxide has some baggage for sure. So to find a better aerosol, these researchers created a model, a 3D virtual climate model that shows the interaction of a given aerosol with the atmosphere. And apparently, from what I've read, it's a pretty cool model, so to speak. It calculates how the different aerosols would reflect light after they're injected into the atmosphere, reflect light and heat, how they would each eventually settle to the ground, because even if you throw them into the stratosphere, eventually they're probably going to come down. So the model calculates how long that would take and what that would be like. It also calculates whether the particulates would clump together. That's really important. You do not want your aerosol particulate matter clumping together. That's called coagulation, and that's bad because it causes warming by trapping heat. And that's the last thing you want with this. So the researchers tested 7 aerosol candidates with this model: calcite, diamond, aluminum, silicon carbide, anatase, rutile, and sulfur dioxide. The model showed that over 45 simulated years, the best candidate would be synthetic diamond dust, because that reflects more than all the other substances tested. Also, the diamond dust is pretty good in that it stayed aloft in the stratosphere for a decent amount of time, and it wasn't likely to clump, which is also pretty big. They also noted that since diamond is chemically inert, we probably won't experience anything like acid rain from the diamond dust as well. So the bottom line suggestion from the model was that if we injected 5 million tons of synthetic diamond dust into the atmosphere each year, it would cool the Earth by 1.6 Celsius in 45 years. Yep, that's a long time. That's a long time, but that's a dramatic cooling, and that's basically how much we have warmed ourselves at this point. It would kind of take us back to where we were quite a while ago. What do you think that the estimated cost was for all 40 some odd years?
$10 trillion.
Times 20.
200 trillion?
Whoa.
200 trillion.
Oh, gosh. We'll have to fill out an application for a loan.
So, but 200 trillion over 45 years or so?
That's still real money.
It's still, yeah.
Yeah. 20.
That's a lot.
Yeah, but what's the cost if we don't?
At what cost?
Well, that's it. Part of the problem is, we don't, if this tipping point's a thing and it happens, we won't know quite what the cost will be until it happens. We're like, oh boy, this is even worse than I thought it would be. But either way, we've got, it's got to be dealt with, and we're clearly heading to a bad place. Even if there is no tipping point, it's going to just get hotter and hotter. So, all right, let me finish up here. So will this research continue? I don't know, maybe, probably, but it might not make a difference as to what kind of aerosol is used if they do decide to do some sort of geoengineering here. At least according to Douglas McMartin, I got an interesting quote from him. He's an engineer at Cornell University. He said, I do think that it's interesting to explore these other materials, but if you ask me today what's going to get deployed, it's going to be sulfate. What I gather from that is that even this research won't sway the people that are going to invest the money to try this stratospheric aerosol injection. That he thinks that they would probably stick with the sulfate, and probably because we know so much more about how sulfate reacts with a large scale deployment because of volcanoes. There's a lot of data gathered there, and I think that's the one that according to this guy, he thinks that they're going to stick with that because better the devil I guess. So who knows? But it was an interesting read. I recommend checking it out online and cross your fingers.
Yeah, not for that kind of money. It's never going to happen.
Yeah, no.
All right, thanks, Bob. All right, Evan, this segment I titled, That's No Exomoon.
Nice.
Well titled, Steve. Well titled. I have a couple of questions for you to see. I'm going to test your memory a little bit. Do you remember when the first exoplanet was discovered?
Yeah.
Do you know the year?
4-1.
Was it
1996?
92?
Oh, Bob, you nailed it. 1992.
Yeah, baby.
Absolutely. That was number one. Now, here's the second one. How many exoplanets have been confirmed?
I think we're around 5,000.
Yeah, I'm thinking 5,000 too.
Just north of 5,000.
Yep.
5765 was the official count as of about 10 days ago. And do you know how many candidates that are unconfirmed?
It's now? Like 3 times that. It's like 10, 15,000.
It's about 8,700.
Okay, yeah.
Roughly 8,700. So now here's the question. We're going to get to where Steve brought this in, the exomoon. How many exomoons have been detected and confirmed?
I think confirmed, the one you're going to talk about tonight. Possibly, I remember reading about one like a year ago, a possible exomoon that, I don't know. So it's probably
it's 0.
Yeah.
Yep.
Zippo.
It's 0.
Wow.
0 confirmed, yeah.
5,700 confirmed. 8,700 more candidates, 0 moon. What does that mean? Shouldn't we be finding exomoons along with the thousands of different exoplanets we've detected?
They're a lot smaller.
They're a lot smaller.
That's one of the reasons. They are much smaller and too dim to detect the dip in light using the transit method that we use for many of the discoveries of the exoplanets. Now, also, there are other things. The signals produced by an exomoon, that can easily be masked by the much stronger signals from either the planet or its star. And you can't really detect the gravitational influence that it has. It's way too subtle. There's also orbital complexity issues. because the motions of exomoons, that's more complex than actually the exoplanets, which is more predictable. So that feeds into this as well. And this is with the most sophisticated equipment we have. James Webb Telescope, the TASS, the Kepler Space Telescope, HARPS, the Very Large Telescope, the GPI, the Gemini Planet Imager. Those are our chief instruments looking at these things. Can't find the exomoons, can't pinpoint them. And, because, and whether you use any kind of method, transit method, radial velocity method, astrometry method, the pulsar timing method, all these methods of detecting the exoplanets, they're not working on finding the exomoons. Well, until maybe there needs to be a new method to find them, and they may have found it. This is the news. Astronomers have apparently discovered evidence of an exomoon orbiting the planet WASP-49b, which is a gas giant exoplanet that orbits a yellow dwarf star known as, what? WASP-49, right? But it's only about 635 light years from Earth. Relatively close. Almost in our backyard. The exomoon candidate of WASP-49b is very intriguing because it might be volcanic. And volcanic in a similar way of one of the moons in our own solar system, Jupiter's moon Io, which is the most volcanically active body in the solar system. Mm-hmm. And you know why Io is volcanically active?
Because of the tidal forces Jupiter.
Tidal forces from the Jupiter.
Yes, that's right. Yep. Cause the interior of Io to flex and contract, creating dense lava flows that break through the surface. So it spews lava into space with sulfur dioxide, sodium, potassium, other gases, creating a massive cloud around Jupiter up to 1,000 times the planet's radius. That's active. So what were the astronomers able to find out about WASP-49b? They were able to detect a massive sodium cloud near the planet. Now, the cloud exhibits behaviors and characteristics akin to those formed by volcanic activity, such as the emissions that we've witnessed from Io. So they used that information to say, hey, this could be happening here as well. The scientists were able to determine that the sodium cloud was not consistent with being produced by the planet or the planet's star. So what that did was open the possibility of another body, possibly a moon, being the source. The sodium cloud appeared to move independently of the planet, suggesting a distant object orbiting WASP-49b on an 8-hour cycle. This study was led by Apurva Oza, former postdoctoral researcher at NASA's Jet Propulsion Laboratory, and he's now a staff scientist at Caltech. And he had colleagues from NASA JPL and researchers from ESO, which is the European Southern Observatory, the Indian Institute of Astrophysics, Caltech, IPAC, NASA Exoplanet Science Institute, the Institute of Science Technology, Austria, and there's even more. It's a long list of people who kind of contributed to all this. And the paper was recently published in the Astrophysical Letters. They used the Echelle spectrograph for rocky planets and stable spectroscopic observations. That's espresso as a, ESPRESSO, along with the VLT, which I mentioned, the Very Large Telescope. And those were the instruments that they were able to use to detect this particular cloud. They estimate the cloud is replenished at a rate of 100,000 kilograms or 220,000 pounds of cloud debris per second. So this thing is being replenished. They had multiple observations of this, and because the cloud would suddenly increase in size. They also discovered that the cloud was moving faster than the planet, and that also suggests it's being generated by another body which orbits faster than the planet. Quote, "We think this is a really critical piece of evidence," said Oza. "The cloud is moving in the opposite direction that physics tell us it should be going if it were part of the planet's atmosphere." Their observations also noted something interesting about WASP-49b that orbits its parent star every 2.8 days. During that time, the cloud appeared and disappeared behind the star or the planet irregularly. So a lot of evidence here pointing towards volcanic activity on a moon around WASP-49b. Perhaps, they still need more information. Perhaps this will become the first confirmation of an exomoon, finally.
That'd be cool.
That'd be cool.
Yeah.
Yep.
All right. Thanks, Evan.
You got it.
Kara, you got a special Halloween-themed news item for us. You're going to tell us about the psychology of being scared.
This one's for Bob.
Cool.
Bob knows all about
it. Bob already knows all the answers. Bob, this is a quiz for you. No, this is just a post that was written by Sarah Collett on The Conversation, and it's really about why do people who she actually wrote it in a I'm just going to quote her because I think she said it better than any of us could. To some people, the preoccupation with horror can seem pretty tone deaf. School shootings, child abuse, war, the list of real-life horrors is endless. So why seek manufactured fear for entertainment when the world offers real terror in such large quantities? Well, and then she said, as a developmental psychologist who writes dark thrillers on the side, I find the intersection of psychology and fear intriguing. And then she goes on to talk about some of her research and some of the research that she's come across that may help explain why we enjoy putting ourselves in situations that are scary. So I'm curious, before I even dive into her slicing and dicing and categorization of the answer to that question, what are some of the reasons that you all think that it's fun to be scared?
Excitement with limited risk.
Because this is an aphorism in the in like the amusement park industry and stuff. Fear minus death equals fun.
Okay, but why does fear minus death equal fun?
I mean, it could be. I always assumed it was for the same reason that we like to play games, to simulate combat. It's like we're simulating stressful situations so that we are able to handle them better in real life. That would be like the evolutionary explanation. And when you do get stressed out and then there isn't the death, there isn't something bad doesn't actually happen, you have all this energy that you have to release. And evolutionarily, we release that energy as humor or a positive emotion.
Interesting.
Yeah, the brain chemicals.
The brain juices. So interestingly, she does really touch on the former that you mentioned, Steve, but less so on the latter, but there's maybe like a twist on that. And so it's funny because that's one of the points that she makes later in her article. An ounce of prevention equals a pound of cure. And the way that she brought that up was to talk about COVID. So I don't know if you guys remember, and I was totally one of these people, but early on when lockdown started, everyone was watching Contagion and Outbreak.
Oh my God, that's right.
They trended and there were these huge spikes in viewership. And I definitely was one of those people. And the idea here is that, watching these threats play out in a controlled way, in a manageable way, maybe would help us prepare for our own experience. And so there's actually a lab in Denmark called the Recreational Fear Lab, where researchers study recreational fear. And they found, and they published it in 2021, pandemic practice, horror fans and morbidly curious individuals are more psychologically resilient during the COVID-19 pandemic. So they found a few things that people who historically self-identified as horror fans, people who watched, horror films for fun, when tested, also self-reported less psychological distress during the pandemic. They also found that people who both enjoyed horror films and enjoyed the prepper genre, so kind of like zombie apocalypse films and things of that nature, they were less psychologically distressed and more prepared for the pandemic. And they also identified a trait that they called morbidly curious people, and they developed a scale for testing it. And they found that those who were morbidly curious had greater resilience during the pandemic. So, and also then it became this feedback loop because people who were morbidly curious were also more interested in watching films about pandemics during the pandemic. But that very much, I think, I fall into that category for sure. I think I am a morbidly curious individual. But that speaks exactly to what you were saying, Steve, that there may be some evolutionary advantage to preparing yourself for fear by coming up against fear in a safe way. So if we approach things that are anxiety inducing, if we approach things where we may need smart action. If we do it in a controlled way, ride a roller coaster, watch a horror movie, engage in a lot of conversation about the pandemic or entertainment around the pandemic, we may be more prepared. She talks a little bit about crime fiction and how she writes quite a lot of psychological thrillers, and that doing these kinds of things give her a sense of control around difficult concepts that we can't always control in the world. So consuming narratives or writing narratives might help her mentally rehearse how she would handle them if they happen to her in real life. So that's kind of interesting. She also brought up two other reasons. One is social motivation, this sense of belongingness. And there's quite a bit of evidence I think of it as like the Speed effect. Do you guys remember Speed?
Yeah.
Do you remember there's like a scene in Speed? I'm really digging deep. I'm not quoting the movie at all here, where they like kiss or something at the end. And like, there's a great exposition about how when people's lives are threatened together, they like grow really close. And they feel safer around each other.
In combat, something grows between people experiencing it together.
Absolutely. And there's a fair bit of evidence to support exactly what you said, Evan, that combat veterans who serve together, people who survive natural disasters, groups of first responders develop these really strong bonds to one another. And that very often people who go to haunts, for example, or who go watch horror movies together, they feel closer in those experiences.
Huh. What if you go to a haunted house alone? What does that mean?
Yeah, I don't know. Maybe then you're trying to find your people.
Well,
but right? Maybe you're finding other people who have similar, and that's a place where you might bond with new people.
For me, it's the artistic aspect of how the haunt itself.
Oh, right, because
you're on more of a research mission.
Yes.
An analysis.
True.
Right?
I'm an anomaly.
And so there's also this theory in social psychology called the tend and befriend theory, or the tend and befriend system, not to be confused with fight or flight, which we will get to, which is that when we perceive threat, we will tend to our offspring and we will befriend those with whom we already have developed social emotional bonds. And that, there are different neurotransmitters and hormones that are released during those experiences that may reinforce it, oxytocin being one of them. So if you're experiencing stress, but you're around people who you already have established as being safe and who you've already established positive social connections with, you may experience a true kind of biopsychosocial, but heavily, I guess, influenced by your biochemistry reaction that then deepens those bonds. So that's kind of an interesting take. And then finally, and I actually did it backward because she starts with this, the subheading is fear can feel good, right? Like this sort of goes back to what you were saying, Evan. It equals fun, right? Did you say that?
Yep.
I did.
Oh, that's Bob. Sorry. But you both kind of.
I'll take credit.
All right. Bevan, this idea that, and I talk about this a lot when I am working with patients who struggle with anxiety, that we have a biological or a biochemical or a somatic experience in our body when we're exposed to threat. Right? That what we call fight or flight, that sympathetic reaction. Adrenaline surges, we start to become sweaty, our heart races, our blood pressure goes up, all that good stuff. That reaction is physiologic, but how we then appraise or interpret that reaction is deeply psychological. So for some people, that feeling is interpreted as fear, and for other people, that feeling is interpreted as excitement. And very often it's somewhere in between. And so when we feel afraid, we often have the exact same physiologic reaction as when we feel excited. And when it's safe, when you know that you're not at risk of harm, that psychological appraisal is a little bit easier. And so you have this kind of physiologic reaction that's fighting with the psychological reaction. And it's like a safe fear. And very often that safe fear can be exciting, but there's something that happens after a sympathetic reaction. What's that?
Parasympathetic?
A parasympathetic reaction. Right. You could call it a crash. But that crash is actually, you actually have a lot of good feelings during a parasympathetic reaction. One of the feelings I don't like during a parasympathetic reaction, have you guys ever experienced this where you had a really intense sympathetic reaction and then you notice the parasympathetic response setting in? Well, I have a very specific situation where I was with a friend once and we witnessed a terrible crash where a bicyclist was hit by an SUV and he wasn't wearing a helmet and we had like a front row seat to it because we were right at the light and it was horrifying to watch. And we jumped into, she ran out of the car and just stood over him and then ran back and goes, what am I going to do? And meanwhile, I'm on the phone with emergency services, giving them all the information. So we sat through that. We gave our statements, everything like that. And then when we left, we went to the grocery store, which was where we were headed because we were going to make dinner that night. And this sense of hunger set in because during a sympathetic reaction, you shunt blood away from your gut. And during a parasympathetic reaction, the blood goes back to your gut. And the sense of hunger that set in, I almost vomited because I felt so deeply hungry during that parasympathetic reaction. And it was the first time in my life where I was like, oh my God, this is what the textbooks talk about. I feel this. But other things happen then too. Like you get these big dopamine dumps very often. That sense of relief, that post-anxiety feeling where you finally go, ugh.
That's a good feeling.
And that feeling may be contributing to why so many people do enjoy kind of canned fear. Because the post feeling is often better. And there is some evidence to support this. The post feeling is often better than the pre-fear feeling. And that individuals, here I have it right here, in a study that was published in 2019, results suggested, I'm just quoting the abstract, that the participants' reported affect improved, particularly for those that reported feeling tired, bored, or stressed prior to attending the haunted attraction. So they go in, they're scared during, afterward they feel relaxed and good and lovely. And that feeling is better, than the pre. So there's a lot of reasons that we like.
You got to be scared to experience that?
You don't have to be. Now, I didn't say that it was necessary to do it, but that it is a reaction or a result from it. And so, the author kind of ends her piece with, the next time you're choosing between an upbeat comedy and a creepy thriller for movie night, pick the dark side. It's good for your health.
That's awesome. I approve this message.
All right, Jay, it's Who's That Noisy time.
All right, guys, last week I played this noisy. Any guesses, guys?
Nothing that'll be correct.
All right, so I'll say right out of the gate, I had a lot of people email in this week and got it perfectly correct. I still find this really interesting and definitely worth talking about. So Alex Freshy wrote in and said, Jay, oh my God, it has to be a Honey Mario or Mario. I don't really think that's the answer, but I cannot hear anything else. So in case you don't know, Honey Mario is what? It is one of the characters in the world of, Mario. If you look up Honey Mario and you listen to it, you'll hear something very funny. I have another guess here. A listener named Diana Gumber wrote in and said, hello, Jay. On a recent episode of Lateral with Tom Scott, one of the riddles was about a recording of an old woman telling wartime stories that is played at the edge of a forest in Ostrobothnia, Finland, right? I probably did not pronounce that correctly, so forgive me. Because it's so fresh in my memory, I'm going to guess that the noisy is that recording. I thought this was a really interesting guess, and of all the funny guesses or incorrect guesses that I got, I think this one, is a really good guess because of, of all the details and everything. It's not correct, but I really did like that guess. Okay. So like I said, I had many people, email me in the correct answer, but I'll mention two of them. The first one is Patrick McComb and the second winner is Bill Z, who both guessed correctly that this is, you guys don't know who it is, huh?
I know it's Helen Keller.
It's Helen Keller. Yes. So this is Helen Keller. I have the recording of her talking and then the person that interprets what she said. So let's listen to that.
If I had only acquired my children's spirit. Long may I feel how much more good I could have done if I had acquired normal speech.
What year was that?
Wow, that's a good question. Let me look that up.
It's such an interesting thing looking back to yes, it was 100 years ago, I guess now, but looking back to not that long ago and noticing the differences in the affectations and how people spoke. Like her interpreter has this very intentional voice.
Without a doubt. I made that observation as well. It's almost theatrical.
Yeah.
The way that person is speaking. So Helen
And when
Keller,
you go back farther than that, you almost hear Britishisms in the American accent.
Yeah.
Mm-hmm. It's just fascinating.
Helen Keller was born in 1880 and died in 1968. And I bet you that is probably from the late 40s and 50s, I think.
I bet you it's a little older than that, but it could be. Even when you look at film from the 40s and 50s, the voices are quite affected. I mean, I say affected. That's just how people talked.
Yeah, it's an incredible thing to try to even guess, for people who have their sight and have their hearing. Mm-hmm. To try to even understand what it was like being her, like, the first part of her life, she didn't know how to communicate, and therefore she did not know how to think. And she describes that later in life. She talks about how she couldn't really think without language. Mm. I find that incredible. It just blows my mind. And it's a scary thing to think about as well, right? Like, imagine being in that state where you're feeling things, you're experiencing things, but you can't explain anything to yourself in any way. You don't really comprehend anything. I don't know. That's profound.
Yeah.
All right, so that's cool. Congratulations to those who guessed correctly. Not just the two winners, but everybody. Lots of people guessed correctly. I'm glad that so many people know about her. But we must shift now to this week's Noisy. This week's Noisy was sent in by Farah Shimbo. Check it out. Now, I will ask you, because many people sent in this Noisy, and it's a great Noisy, and I just like it because it also has like a creepy Halloween type of vibe going on with it. But if you sent it in, and I know you know what it is, then don't guess correctly. Let people actually try to guess what it is. I just think that'd be more fun to hear what people have to say. So if you sent it in, just don't bother. I know you know it, and I will check. And if you do it, Steve's going to get angry and he'll hit me.
And you don't want to see me when I'm angry.
No. All right, so you can email me at wtn@theskepticsguide.org if you heard something cool or if you want to guess this week's Noisy. Steve, there are announcements.
Let's hear them.
All right, so first and foremost, if you enjoy this show and if you really feel like the work that we do is valuable, then please consider becoming a patron of ours. You can go to patreon.com/Skeptics Guide. We have different levels. All of them will go to help us continue to do the work that we do and to expand what we're doing. I really appreciate it if you would think about joining us. You could also become a part. You could get our mailing list. The SGU has a mailing list. We send it out every week, and it contains everything that is happening or has happened the previous week. And we'll also be telling you about things like, Nauticon and events that we're going to be at and all that. So if you're interested, just go to theskepticsguide.org and you can join our mailing list on our homepage. If you are inclined, you can also give our show a rating on whatever podcast player you're using. It helps people find us. We have 3 shows coming up, guys. We're going to be in D.C. on December 7th, and we have 2 shows that day. We have a D.C. private show, and we have a D.C. extravaganza. We do these shows with the entire SGU crew and George Robb and Ian, who, the watermelon guy. You might know what I'm talking about. He will be there as well. And if you're interested, just go to theskepticsguide.org. We have buttons on the homepage, or you can go to our events page and you can find out more information. Last but not least, guys, Nauticon 2025. People are buying tickets.
Yeah.
The board game, the boardroom board gaming thing sold out. Sorry about that. That is sold out. But there are still some VIP tickets left. And of course, you could always just buy the main tickets for the conference. This will be May 15, 16, and 17 of 2025. You can find out all the information. If you're curious, just go to notaconcon.com. Did you follow that? Notaconcon.com.
I got it.
Okay, thanks, Jay. Guys, we have one email, which is really a cluster of emails. We're just going to talk about them all at once. We had a number of responses to our kind of off-the-cuff discussion about battery replaceability in smartphones and in laptops. We kind of mixed the discussion together, and people were often responding to one versus the other. But the concept is the same, that over the years, like over the last 20 years, it seems that, I know the smartphone came out in 2007, but even longer for laptops, that replaceability, repairability, upgradability has been sacrificed in favor of small, slim profiles. And so we had a number of people respond to that. A couple people pointed out that, especially for the smartphones, there's a reason other than a slim profile why they may want to make the batteries more, unable to remove the batteries from. Do you guys, did you see those emails?
Yeah, that it's waterproof.
Yes.
It makes it waterproof. Yeah, it's harder to make it waterproof if the battery is removable. If the case is...
Yeah, if you can open the thing.
You can open it and there's contacts and everything, yeah. Mm-hmm. But if it's all integrated and sealed, it's easier to make it waterproof. So that's
pretty new, to be honest.
Yeah, it is.
Like, waterproofing is... I mean, maybe there have been versions of it in the past where it was semi-water resistant, but... you remember the days of like the water damage.
Yeah,
you would take your phone and just drop it in the toilet. Yeah. And they were like, you dropped this in your toilet. And you're like, no, I didn't. They're like, the sensor inside says you did.
Toilets. That's crazy.
Oh, that happens to women all the time. That doesn't happen to you, huh?
It's never happened to me.
So because we will wear our phone in our back pocket and then we'll sit down to pee. And you forget your phone's in the back pocket.
Oh, gosh.
Yeah.
It's only almost happened to me when I'm using my phone while peeing standing, right? That's
okay. That would make sense.
Yeah. What are you reading while you're peeing? If you're
whatever. Somebody
want to read.
So I get
there was a period in my life where it happened constantly to me. Constantly. I had
put it in your front pocket.
Desiccant. No, you can't. I'm a woman. Yeah. Have you ever seen a pair of women's
pants? I know.
Pants?
They don't give you front pockets.
No. They're like 2 inches deep.
Yeah.
Is there reasoning for that? Does it not look good?
Here we go. Problem? That'll be next week's email.
Welcome to the patriarchy.
My daughters complain about it all the time, the lack of front pockets or pockets in general in female clothing. Yeah.
Yeah.
I don't...
Anyway.
Yeah, so there's that. There's the waterproof thing. And a lot of people pointed out that it's not universal. There are definitely brands that make other choices that for laptops especially there is
but they're not dominating the market.
They're not. Yeah, like one of them was like, you guys may never have heard about this. It's the framework laptop that it's essentially customizable and upgradable and all that kind of stuff. So basically going in the opposite direction. Mm-hmm. And which is interesting because these trends do change, like technology trends change in response to technological advancements as well as in response to how people use things. And we're a little bit biased, I think, because I think we lived through like this main period. Like, do you remember when the trend for cell phones was to get smaller and smaller and smaller and smaller?
Yeah. Yes.
And then as soon as smartphones came out and the real estate of the interface was important, then they got bigger and bigger and bigger.
Yeah, but also to be fair, I feel like there were a lot of emails about that. And when I was making the point, like smaller, I meant thinner.
Yeah, thinner, lighter. This is not related to what you were saying, Karen. I'm just saying this is an example of a reversal in a technology trend. Mm-hmm. So I definitely, there was a time when definitely for laptops, I think it's more complicated for phones, but for laptops, they got smaller, thinner.
No, I think it's the same for laptops as it is for phones. Like, some people want a really big screen, some people don't. Mm-hmm. But you still want everything else to be as thin as possible.
Right. Other than the screen size, this is we're talking about two different things. You're right.
But the screen size is what dictates the size of the laptop.
But at any screen size, there's a trend towards thinner laptop
100%.
and lighter, thinner, lighter.
Yes. And same with phones. Yeah.
And therefore slimmer. We'll say like a slimmer profile. But I don't think that trend is necessarily universal, or it may not be holding up because things have shrunk so much it doesn't matter as much anymore. It mattered when like the bulk of your laptop was like the most important feature of it. You know what I mean? Like a slimmer laptop was really nice to have. Now I wonder if it's just that, well, you can market a laptop that's not optimized for slimness because the technology is so slim at baseline. You could now start to incorporate other features like a replaceable battery, or it's easier to upgrade, or it's easier to repair, or whatever.
Yeah, and I wouldn't care if laptops never got thinner than they are right now, but they just kept getting lighter. I would be thrilled. Mm-hmm. You know, I think lighter matters more.
At this point, I think it doesn't. For me, it doesn't really matter. You know, the weight or the slimness, whatever. I think they're all fine. If they stayed as light and slim as they are now, but were easier to upgrade and repair and swap out the battery, I might go for that feature. Like once it gets to a certain size, getting even smaller is less and less valuable, right? I guess is the point I'm trying to make. But
why would Apple, for example, want to sell a modular laptop? Well, they can make so much more money.
I know.
Doing
That's the other. That's another price. Point is there are industry incentives that are, not necessarily consumer incentives, but industry incentives that work here. That's hard for us to know because we're just consumers.
And definitely not environmental incentives.
Right.
Fair point to bring up, though.
I know. But I think here's another thing. Battery life has gotten so much better. Like definitely for smartphones, they basically last the life of the smartphone now. Whereas like 10 years ago, 15 years ago, I would replace my smartphone when the battery stopped working. Now I replace it when the camera upgrade is enough to make it worth it. You know what I mean? Like my batteries, I have a 3-year-old phone. My battery's fine. I still go all day. It's not a problem.
Oh, mine's not. I still replace it because the batteries.
Yeah. Maybe it depends on how you use it.
It's just how many times in a day you end up having to charge it.
Never more than once.
Oh, yeah. Well, my phone's pretty old, I guess.
Yeah. But these are the kind of things I'm talking about where like there's the technology changes, like the premium changes too. Battery life is now so good it's not that big a deal anymore. Like you remember, again, having lived through the entire computer thing, from the 80s, 90s and beyond, remember when we were obsessed about certain features of our computers? Like we were obsessed about the clock speed and, all that stuff. And now I couldn't even tell you what my like the megahertz and the gigahertz, whatever. Now it's like not an issue anymore. It's super fast. It's faster. You know what I mean? Like being a little faster is not a big deal. Hard drives are kind of that way now. I mean, I kind of still need to like pay attention to hard drive space because I literally because of the show I produce gigabytes of info. Yeah. But I think for most people, it's like whatever. It's giga whatever. It's like I have a 2 tera whatever drive. It's more than I'll ever need, and that's fine. And people aren't as obsessed about it as they used to be. Right? Like those kind of numbers used to matter more to the everyday user. Now they don't really because they're so much better than what everybody needs. Unless you're a gamer, right? If you're a gamer, then you absolutely obsess about all of these because mainly about your graphics card, but you're pushing the limits of it, then you do worry about that kind of thing.
And if you're a producer, a creator, if you're making music, if you're making film, if you're making, audio on your computer needs to be fast and it needs to hold a lot.
Yeah. Yeah, but for most people, it's like, you just want it to look pretty and be not too heavy and whatever. The battery will last fine. Yeah, the upgradability for laptops is interesting. I always, and this is something that's happening, is that the time between getting new computers and feeling the need to upgrade my computer is getting longer and longer and longer. Do you guys experience the same thing?
Yeah.
It used to be like a year after I got my computer, I was jonesing for a RAM update or a bigger hard drive. Now it's like, I don't even know how old my computer is.
I never upgrade. For me, I get a new computer because something on my computer critically dies, and to fix it would cost half the price of a new computer. So I might as well just get new technology.
Yeah, right. Yeah, that's true.
My iPhone's 6 versions behind at this point.
Yeah.
What are they on right now?
I'm ready to upgrade. I can't wait.
Do it.
But it's mainly for the camera.
Yeah.
Yeah.
The huge camera upgrade. Huge. But everything else, it's more incremental.
I said this offline, but I have a 13 mini, and I don't want to. I'm going to drive it into the ground because they stopped making the mini after that. I don't understand why. There has to be
Sales.
A lot of people.
It just
like
wasn't
me.
selling as much. It's not worth it.
It's so bizarre to me that more like smaller, like slighter women don't want a smaller phone that fits in their pocket. They're so big now.
People prioritize different things. It's all trade-off, right? It's all different trade-offs. All right, guys, let's move on with science or fiction.
It's time for science or fiction.
Each week, I come up with 3 science news items or facts, 2 real and 1 fake, and then I challenge my panel of skeptics to tell me which one is the fake. There's a theme this week. The theme is the oldest. So I've done this before. It's 3 things claimed to be the oldest of its thing. These are all cultural things. Okay? Culture, technology towards the thing. Are you guys ready?
Okay.
All right, here we go. Item number 1, the oldest extant building in the world is the stone circular tower of Tel Quaramel in present-day Syria, which is about 12,000 years old. Item number 2, the oldest example of metallurgy is copper smithing artifacts from 7,500 years ago in modern-day Serbia. And item number 3, the oldest example of literature is a 7,000-year-old cuneiform tablet, the goddess of creation, from Liangzhu culture in modern-day China. Kara, you go first.
Who knows? Okay, 12,000 years ago. So that's like 10,000 BCE. And when you say the oldest extant building in the world, like you're not talking about ruins.
So there is actually criteria for what counts as a building as opposed to ruins. And there just basically has to be complete enough that you consider it's an actual building. It's not ruins. So this is the oldest one that meets those criteria.
Okay. Yeah. So it's kind of random and arbitrary.
It's a little arbitrary, but it's intact enough that it counts. Yeah.
Okay. Sure. And then we've got metallurgy. Oh, see, I'm so bad at this. You guys talk about all these different eras and stuff. Metallurgy, copper smithing artifacts from 7,500 in Serbia, and then literature is around the same age. And that doesn't, is there a definition to literature? Like it needs to be portable or something?
No, it just needs to be a story.
Okay.
Yeah, so not just a snippet of something. It's a actual story.
So basically, the building is older than the metallurgy and the tablet. They all seem reasonable to me. Maybe the metallurgy is older. Let's say the metallurgy is younger or older, that's the fiction, but I have no idea why.
Okay, Bob?
Yeah, these all sound reasonable. Nothing's really leaping out at me. So I'm just going to go with my gut and say that the building from 10,000 BC is fiction.
Okay. Evan?
Well, I'll go with my gut and say the example of literature 7,000 years old is the fiction.
Yay, no sweet.
Oh boy, all spread out, Jay. No help from your fellow rogues.
Yeah, I'm gonna go with the literature.
Ooh.
Because I thought that Gilgamesh was the oldest.
That's what I thought, Jay. Yes, Gilgamesh, right?
Yeah, so I mean, I don't know.
That was always my idea.
I've never even heard of this, and I am an English major, Steve. So I could write you a poem whenever you want.
All right,
but yeah, now something doesn't sound right about that one. I think that one's fake.
All right, so I guess we'll take these in order. The oldest extant building in the world is the stone circular tower of Tel Quaramel in present-day Syria, which is about 12,000 years old. Bob, you think this one is the fiction. Everyone else thinks this one is science, and this one is science. Yeah, that's damn old is what that is.
To be considered a building, yes. It's the right area of the world, though.
Right.
Yeah, it's the right part of the world, Syria.
And it's made of stone, so that could have happened.
And I can't guarantee you that everyone agrees on where that cutoff is to what a building is. But this is multiple sources say, yep, this is the oldest one. The other one that sometimes gets mentioned is almost as old is the Göbekli Tepe, Tepe, in Turkey, which is 9,500 BCE to 7,500 BCE was when construction was done on that one. And this is, so it's not quite as old as the towers of Tal. There were 3 towers, apparently. One is standing enough to be saying, oh, yeah, that counts as a building.
That's cool.
Yeah, very cool. Let's go on. Number 2, the oldest example of metallurgy is coppersmithing artifacts from 7,500 years ago in modern-day Serbia. Carrie, you think this one is the fiction. And this one is science. This is science.
All right.
So, yeah, there's multiple examples of copper metallurgy from this region, all in this sort of in where Serbia is now. And so they clearly, that culture, that broader culture, had hit upon, copper smelting before anybody else did. This belongs to the Vinca culture. You guys ever hear of that before? The Vinca culture?
Vinca, I've heard of it.
You've heard of it? So yeah, this is a major archaeological find that there was this civilization in this part of what is now Serbia, and they had copper metallurgy before anybody else. They found copper axes and signs of copper smelting as well. So very cool. Which means that the oldest example of literature is a 7,000-year-old cuneiform tablet, the goddess of creation, from the Liangzhu culture in modern-day China, is the fiction because the oldest literature is Gilgamesh. You guys are correct.
Okay. I remember that from a trivia game.
So how old was that?
The Epic of Gilgamesh. So it's an epic poem describing the adventures of Gilgamesh, the king of Babylon, from dates to 2150 to 1400 BCE, so 4,000 years ago. This was like a full epic story of his adventures. He was trying to defeat death, figure out how to become immortal.
Good luck with that.
And was, actually, culturally continuous to modern times, meaning that the Epic of Gilgamesh was influenced Homer's Iliad and Odyssey, influenced stories in the Bible. The cultural connection to modern times is unbroken, which is interesting. Now, there was a Liangzhu culture in modern-day China, which predates the oldest dynasty in China, and they had apparently amazing architecture, a huge city, walled city, but no evidence of any literature from there. So I just made that part up. And 7,000 is way too old.
That's long.
Yeah, for the oldest writing. The writing began with the oldest literature. Writing started as, these sort of cuneiform tablets. Do you know what was the first writings? Do you know what it was for?
Like instructions
warning
or something?
signs to your enemies.
It was just just keeping track of stuff. It was just writing down how many bags of grain do we have, that kind of stuff. And that was like proto-language, and then that evolved into writing and then into stories, and then there were a couple of little poems that didn't really count as quote unquote literature. Again, it's where do you draw the line? But the Epic of Gilgamesh is, everyone agrees that's literature. So good job, Jay and Evan. You guys sussed that out.
Oh, we made up for a bad showing last week, so it all equals out.
Right. Okay. All right.
Made myself feel good right there.
All right, Evan, give us a quote.
I can live with doubt and uncertainty. I think it's much more interesting to live not knowing than to have answers which might be wrong. Richard Feynman.
Mm-hmm.
Yep.
Yeah, it's better to not know than to know what isn't so. Yeah, that kind of idea has been expressed a lot of different ways. And
a lot of different ways.
The illusion of knowledge is worse than ignorance, et cetera, et cetera. Totally agree. Obviously, that's because if you are in a state of thinking you don't know something, then you'll find out. You're open to information. You're curious. Thinking you know something that's wrong is deadly, right?
Steve, this ties back to your news item.
Absolutely. This is not exactly the same thing, but it's in the same ballpark. The illusion of knowledge, the illusion of information adequacy, et cetera. Yeah, very similar. All right, guys. Well, while this show comes up, we will be in Vegas at SciCon.
Yes.
Next week's show is one that we recorded in August, because I'm going to be in Dubai at a skeptical conference.
Wow.
Yeah.
First time in Dubai.
Yeah,
huh?
first time. But it's going to be a whirlwind. I'm going to arrive on a Monday. I'm giving a 12-hour seminar Tuesday, Wednesday, Thursday.
No breaks.
3 4-hour sections. And then I'm flying out Friday. So I'm not going to have too much time to see the city. But I will do what I can, what sightseeing I can.
You got to go up into the tallest building in the world.
Yes.
Of course I'm going to do that.
Go to the roof and take a selfie.
Yeah. So the next new episode will be in 2 weeks, and I'll report about my adventure in Dubai.
Yeah.
Cool.
Can't wait to hear.
All right, guys. Well, thank you all for joining me this week.
Thanks, Steve.
Thanks, Steve.
And until next week, this is your Skeptic's Guide to the Universe. Skeptic's Guide to the Universe is produced by SGU Productions, dedicated to promoting science and critical thinking. For more information, visit us at theskepticsguide.org. Send your questions to info@theskepticsguide.org. And if you would like to support the show and all the work that we do, go to patreon.com/skepticsguide and consider becoming a patron and becoming part of the SGU community. Our listeners and supporters are what make SGU possible.